Okay, hey, hello, and welcome to the Knox Makers KM-004 COVID coronavirus build kit. We did some of these during the pandemic virtually. Now that hopefully we're past most of that, maybe we can build them in person again. Hey, so welcome to this build video. So we're going to learn a little about how to solder, how to build this kit, and how to debug it if anything happens to go wrong. Hopefully it doesn't. So to start, just open up the kit here and pour the contents onto your work surface. Being careful not to let anything fall on the floor and get lost. Don't want your hamster to carry that away if your hamster already got loose. And in this kit, you should have the circuit board itself. You should have a handful of LEDs and a strip of resistors and a switch. Already pre-assembled on this board is the little USB micro port. It's a little delicate, so I went ahead and pre-assembled those for you guys. Okay, in building these kits, these boards, we usually start with the lowest profile components first and then work our way up. It makes the build process more straightforward. In this case, we'll start with these resistors. Now the resistors, they come in a little strip. You can just pull off these ends. These little pieces of paper, sticky pieces of paper. Don't worry about getting the leads a little bent up. You'll fix those as we build the kit. Now resistors can be inserted in their position, either orientation. So you could put them in the front, the back, flip them around, whatever you want to do, it's going to work just fine. So that's the good news. In order to place them, what you'll do is, and the resistors in this kit, they're all the same value, so any resistor can go in any location. And the resistors will go in locations you can see labeled around the perimeter here, R1, R6, R7, or 5, R2. They're going to go in these positions. So to prepare it to go on the board, just take the component, put it between your index finger and your thumb on one hand, bend the leads with your other hand, and let's put it in the board. So you can see I've done that, bent it in place, push it through. Now I'm going to hold it in place with the thumb of one hand, and on the back side I'm going to bend the leads out with my other hand, and that's going to hold it in place on the board nicely while I solder it. So to solder this, I've got my solder iron nice and heated up here. I'm about 725 degrees on my iron. That works for the particular solder, the solder tip, everything that I'm doing here. You may find that you need a little higher temperature than that, possibly. You might be able to go lower. Don't overthink it too much. As long as we get solder to melt, we're going to be doing okay. If you find that you're having a hard time, you might try turning the solder temperature up, the iron temperature up a little bit. That may help you. And as you get more experience, you may find that you can bring it down some more or not. You may like it turned up quite a bit. All right. So in order to solder one of these components, what I need to do is get both the lead of the component and the ring on the PC board both up to the melting point of the solder. So I'm going to take the solder iron tip, I'm going to tin it with a little bit of solder here. And the reason I'm going to do that before I start is because there's flux, a core of flux inside the solder. And what that flux does, it gets released when the solder melts, comes up to temperature, and it cleans off any oxidation that's built up on that tip. So it'll help keep that tip nice and clean. I'll do that a couple times. I can see that the tip is all tinning nicely. It's all taking solder nicely. Everything looks good. I'll wipe the solder iron tip off on my sponge, and then I'm going to put the tip against both the lead of the component and the ring on the PCB. I'll let it sit there for a couple seconds so the solder can flow nicely, pull it away, wait for a moment, and let it cool. Do the same thing on the other side. And you're good. Now, as to how much solder you put on here, it doesn't really matter that much. You could have a big old blob of solder, or you could have a very small amount. As long as you have solder filling the hole in there, wicking up the lead, wicking around the ring on the PCB, you're going to have a good solder joint. It's going to work just fine. So at this point, I'll take my little side cutters here, cut the leads flush with the board, and I have my first component soldered in place. That's all there is to it. So I'm going to go ahead and place all the rest of these on the board at one time, or solder them all in one time. When we talk about solder iron sponges. There's a lot of heated debate at times over what the best solder is to use, what the best iron, the best everything. Really, most of that doesn't matter. Again, if you're sending a space shuttle to Pluto, fine. Go make a living about it, but building things in a makerspace like this, what we're doing here is just going to be fine. Whatever solder you use, as long as it's made for electronics, don't use plumbing solder, it's going to be fine. Whatever temperature you use, if you're getting up to temperature, it's probably fine. Try to keep it under 800 degrees. Over about 800, you start to deteriorate tips much more quickly, and you get more and more likely to actually damage something while you're building things. But for now, just focus on getting what appears to be a good joint. I have both a brass sponge here, they call it. Looks kind of like a gold-colored Brillo pad, and a, whatever you call it, a normal, I think of a normal sponge, like a little foam sponge that holds water. Either of those work fine. I use whatever's at the station I'm at. I've used both of them for many, many years, and I would say they both work pretty equally well. I don't notice a difference in tip life or anything with those. Okay, so I've got all my resistors inserted. I can look at the board and make sure that, yeah, they're all sitting nice and flush. They look pretty good. I'm happy with it. Now I'm going to go in and solder all of these connections. So again, make good contact with both the lead and the PC board exposed metal. Feed a little solder in and call it good. All right, so I'm now finishing up my last resistor. These are all soldered in place. I'm going to tin my tip one more time. It's always a good habit to tin your solder iron tip before you put it in the holder. That solder that's sitting on the tip will help kind of encase it and protect it from being exposed to air. And the oxygen in air is what will oxidize the tip and make it not work as well, not last as long, deteriorate it over time. So tin your tip, put it in the work holder, or whatever you've got, and then we can trim the leads off. Again, it doesn't really matter how flush they're trimmed. You could leave a little bit of lead sticking off. They can be trimmed so flush that you're cutting some of the solder in half. It's going to be fine. Got a couple extra resistors in here. I'm just going to set those aside. I don't need them. I'm going to take a look across the board and see, am I happy with all my solder joints? Does everything look good? Did I forget any? Do any look like they really don't actually have much solder or any solder on them? I'm pretty happy with those. So we're going to move on to the LEDs now. Now LEDs do have an orientation. There is a short lead on LEDs and a long lead on LEDs, and if you feel the edge of it, you can feel there's a flat side. I can feel the flat side is on the short lead, and that should always be the case. I have seen LEDs where some of this stuff is backwards. Very unusual. Hopefully there'll never be any in these kids. So the long lead is the anode. It's a higher voltage side. The short lead is the cathode, the lower voltage side. The cathode, the shorter lead, or the side of the LED with the flat on it, is going to go to this square pad that has this solder mask line next to it. So that's how you can determine the orientation of all the diodes on here. So short lead, or the flat on the edge of the body of the diode, to the line, the solder silkscreen line. Or the square pad. So you do need to get these oriented correctly. If you put them in backwards, it won't damage anything, but they won't illuminate. and it will be difficult to fix later. Pretty easy to flip them around now, pretty hard to do it later. So also with these LEDs, I am trying to be careful to get them nice and flush. Nice and flush and pointing straight up. So if an LED is kind of sitting a little bit crooked somehow and not pointing straight up, it will emit more light, a little off to the side, off axis to where you're looking at the board. And that LED will appear to be dimmer. So it won't look as nice and even. So I'm pushing the LED nice and firmly against the board with my finger on the other side as I bend the leads out on this side. I'll get all these LEDs in place and then we'll go to soldering them. Hopefully, I do all these with the correct orientation and don't get distracted because I'm paying attention to talking and not building. It's probably happened before. All right, so I can eyeball this, and I can sort of see on the back, I can kind of check each of these LEDs to see that the lead that appears shorter. Look at that, I found one that's backward. I'm glad I checked, huh? The lead that appears shorter is on the side with the line, the silkscreen marking on the board. I'm glad I checked that. Okay. Yeah, what they say in woodworking, measure twice, cut once. Sometimes. I just built a board where the markings were the exact opposite of this. So I've put two of them in backwards. They're the exact opposite. There was a marking where I was putting the long lead with the marking instead of the short lead with it. So I'm going to do a second check of all this. My brain may be in auto fire mode, putting the wrong lead with the marking. Okay, let me check these one more time. Looks good, looks good. If you've never soldered an LED in backwards, you haven't built many boards. That's what I say. Okay, I think these are all right now, so let's find out. I've got a couple extra LEDs. I'm just going to put those aside. Okay, just like the resistors now, we're just going to solder each of these connections in place. Make good contact with the lead and the board. Flow some solder in. And then move to the next connection. Between every component or a couple of components or a few components, just reach over and wipe your solder iron tip off to keep it nice and clean, and keep going. You may find it easier to trim off some of these leads as you go. If, say you thought a couple of these leads were in the way, you can just come on in and cut them off as you go and open up some space to work. Can be a lot easier if you've got good access to get your solder iron tip in at whatever angle you want and feed your solder in at whatever angle you like. You may find that to be easier. Okay, so you should now have all your LEDs soldered in place and all your resistors soldered in place. The last part is the switch. So the switch actually does have some plastic inside it. It's not super fragile, but we do want to try to get on this and solder it and get off and not linger on the leads too long and end up melting that plastic. It's somewhat heat tolerant, but you know, it is plastic. So to place this switch on, you could actually do it either way. It would work either direction. There's not an orientation to it. In this case, there could be, switches often do have orientations. In this particular case, you could really do it either way. I place it this way because the switch is easily accessible from the outside when I grab the PC board. So we take the switch, place it in, keep it in place while you flip the board over. Now when you solder this, the outer leads are connected to the metal housing, so they might take a little bit of extra heat. It might take an extra few seconds to get them up to temperature. And the middle lead should be about like what you've been seeing so far. So try to place a little bit of pressure on the board to make sure that the switch is making good contact on the bottom there. And it feels pretty good. Then I come in, I want to solder one of these outside connections. It's taking an extra few seconds there for the heat to penetrate everything. And now it's soldered nicely on one side, now it's soldered nicely on the other. Got a little more solder than I needed there, but it'll be fine. So you do want to get on these and get off, but you don't want to go too fast. You do need to give it a couple seconds, let the solder flow. So, you know, try to get on or off in a few seconds. All right, the moment of truth. Let's hope I figured out each of those LEDs I put in the wrong way and got them fixed ahead of time. So I'm going to take my USB cable, plug it in, and hey, look at that. Everything works like a champ. All right, so what do you do if something doesn't work? If none of the LEDs are lighting up, then you either have a bad power source. Is it plugged in? The age-old question from tech support, have you plugged it in and turned it on? So did you plug it in? The switch could be in the wrong position, maybe give it a couple of flips, see what's going on there. If nothing is working at this point, then there's either a bad connection somewhere on the switch, it's probably the most likely thing, so reflow each of those joints again, see if that fixes the problem. If not, maybe it's possible there's something on this jack. I mean, I soldered those on. I could have made a mistake. You could try to reflow, particularly these 2 points. These are the 2 that are really providing, they're both providing ground and power. These other 2 larger connections are also providing an additional ground. So you can check those, make sure those are reflowed pretty well, and you should be working at this point. Some of the LEDs should be lighting up. If not, you could take a multimeter and measure across these 2 leads. You should get about 5 volts, 4.9, 5 volts, something like that. That would tell you that power is coming in from the power jack onto the PC board. If you've got power there, then you can now check the switch. So you can put the black lead of your, or the minus lead of your multimeter on one of these larger joints, larger connections on the USB jack, and then take the red lead and touch it to the center. The center pin of this switch should have 4.95 volts. And then as you change the switch from one position to the other, it should route that 4.9 volts to the left center or right center leads on the switch. If you verify that, then you've got voltage coming through the switch. If nothing's lighting up at that point, the only thing I know to guess is probably all the LEDs are in backwards. Hopefully that didn't happen. Hopefully at this point you got at least some LEDs lighting up. If some are lighting up but not all of them, then there's probably a problem with that around that particular LED. So for example, if this LED was not lighting up, it's probably something with that LED or the closest resistor. So I'd flip the board over, I would reflow the joints, the solder joints for that LED. I can follow that trace from the LED over here and I would reflow the joints on that resistor. Probably that LED would then work. If not, then you most likely have the LED in backwards. You can use the magnification on your phone or something. See if you can find the flat of the LED. It should match that little solder silk string line. If it does, then there probably is a bad LED, which is very rare, but it could happen. If it's backwards, you'll have to remove it and replace it or swap it around. To remove it and swap it around, you can take your solder iron, you can bridge both of those solder connections at the same time with your solder iron, and then pull the component out from the other side gently with some pliers or something like that, trying not to damage it. You may need a clamp or tool to hold it in place while you do that, or a friend, a helpful friend. And that should solve any problems with any remaining LEDs that aren't lighting up. But hopefully at this point you've got a lighted board, you're happy with it, and you're ready to show it off to friends. Hope you had a good time. Hope you learned a little about soldering, and check out some of our other kits. Thanks.